Free body diagrams. First of all, we need to recognize the forces that we usually see. We always have the force due to gravity, which is always down, and it's given by mass times the acceleration due to gravity g, which usually is 9.8 meters per second squared. But if they tell you that it's 10, that is fine, we use it like that. The second force is the normal force, which is always perpendicular to the surface, right? The only way, like, this is how normal force is created. It needs to be perpendicular to the surface. If we talk about the wall, it's like that. If we talk about the ceiling, it will be like that. It's always perpendicular. That's why it's called normal. The third force is tension. Tension has the direction of the rope, starting from this, all start from the center of the masses, going outwards. Friction. Friction opposes motion or even intended motion. So if, let's say, an object moves towards that or wants to move towards there, friction will be the opposite way. It's always parallel to the surface, opposing with the opposite direction. Now the applied forces, well, it depends on the forces that they tell us to use, right? We don't decide, the problem decides what the applied force may be. Now, to do the free body diagrams, we need to have x and y axis. This axis needs to be perpendicular. Man, I don't know where I am. Needs to be perpendicular. And, if there's motion, one of the two axes needs to coincide with the motion. All right, so for horizontal and vertical motions, we use them like that. Oops. But for inclines, we will, the motion will be, if it happens, it will be parallel to the incline. So the x-axis should be parallel to the incline and the y-axis should be exactly perpendicular.